Right, guys, in this video we're going to look at another example on abstract algebra. And the second video here said show that the set n simply denotes what? Natural numbers. So I hope you know what natural numbers are. Set of counting numbers, exclusion of 0, or from 1 to infinity. Of all natural numbers, 1, 2, 3, 4, 5 up to infinity, the dot 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 does not form a group with addition or multiplication, but it forms a semi-group with respect to addition as well as multiplication. So I will take it again. The question said show that the set n of all natural numbers 1 to 5 up to infinity does not form a group with addition or multiplication, but it forms a semi-group with respect to addition as well as what? Multiplication. So this is no different to what we just saw in the first video. So but this one says we should show that it does not form a group. So when we said it does not form a group, that means it may be lacking in one of the axioms. So, and that is what we need to check. And what are those axioms, if you can remember? First is that we need to check for what? Closure property, if it holds. Second is that we need to check for what? Associativity. Third is for check for identity. Fourth one is check for what? Inverse. So what it actually means when it said does not form a group, okay, when it does not form a group, it simply means that it's either we are lacking in what? In the closure, if closure does not exist, or maybe check for associativity does not exist, or maybe check for identity does not exist, or maybe even inverse. So one of it must be lacking. That is why I say we should prove or to check that it does not what? Form a group. So don't forget that. That is the main emphasis. So let's write out the question in this form. So we're going to have remember we're dealing with natural numbers. So and here denotes what? Natural numbers, set of natural numbers. So natural numbers from 1 to 5, that is even up to infinity, due to this asterisk here, this dot dot dot. So we have dealing with two signs of which we need to verify. We said that it does not form a group with what? Addition or what? Subtraction. So we're dealing with now with what? We're going to check for what? Addition. Does it form a group with addition, or does it form a group with what? Multiplication rather. So we're going to check these two things to make sure if it exists. Now first of all, we're going to go over to defining what we actually mean by checking for closure once more. So now according to the definition here, we have that to check for the closure, like I said, we have that a comma b, given any two number out of this set, if we pick any two number that should be element of the natural number, we have that what? A plus, or maybe we multiply either with plus a with b or multiply a with b, it should still give us an element in the what? Natural number. So this is actually what it means. To check for closure is just to pick two numbers. So let's just pick 1 and what? 2. And this 1 and 2 we are to plus. The first instant is to plus 1 and 2, and the second instant is to what? Multiply what? 1 and what? 2. Okay, now if we plus 1 and 2, we're going to get what? 3. If we multiply 1 and 2, we're going to get what? 2. Alright, now we agree because these 3 and 2 are part of a natural number. Alright, so we don't dispute that aspect. So it actually means that closure holds in this natural number. Now we go to the second condition that said check for associativity. Now if you can see it on this board here, we have the associativity. We have three numbers to be picked out of our set ABC, and those three numbers should be element of the natural number. All right, and we have that word in associativity. If you pick three numbers, either you a plus b, use plus in the first place, or you can use times in the first place, but make sure that the bracket covers the last two first, or the first two. As you can see here is the first two, and on the other side is the last two. So that is how to check for associativity. But meanwhile, it is basically have to do with what? Three numbers. So let's pick our ABC to be, let's say maybe 1, 2, 3 to be the three numbers, and this time around let's use plus for these three numbers should be equal to the same 1, 2, 3. Now we are doing with plus right now. So once we're done with plus, we'll now go over to that of multiplication with the same values. So let's do plus now. If we add up this last two, it's going to give us 3 plus 2 is 5, plus this one here now is what? 6. So if we add up the first two, we're going to have what? 3 plus this last 3 is going to be what? 6. So you notice that associativity holds for what? Addition. So we agree with this. Now let's go over to that of what? Multiplication, the asterisk. Now let's check if associativity also hold for 1, 2, 3 equal to 1, 2, 3. Remember, they are multiplying, multiplying, and you don't forget to put the bracket in the appropriate place, the first two and the last two. So let's check this. 1 times, now let's have 2 times 3 here is 6, multiplied by 1 is still what? 6 is equal to, now 1 times 2 in bracket is what? 2, and multiply by 3 outside is going to give us what? 6. So as you can see that associativity also holds for what? Multiplication and also for addition. So let's say these two conditions in this question have been satisfied. Now let's go further, because when he said I should check that it does not form a group with addition and what? Multiplication, it simply means that there must be a place where there is a pitfall. That means there is a place that is not being satisfied. So we have to keep checking. Now let's check for the identity now. And looking at this, look at the question said, the identity explanation, the definition said, if you have A to be element of a natural number, all right, if there exists, are you getting it? So this, if there exists E, element of the natural number also, such that when you have, maybe add up your A plus B, your A plus your natural number, I mean, that is your A plus E. If you add up A plus E or multiply your A plus E, you should be able to get what? A. So that is what it's saying now. So we're going to pick a particular number that when we add to A or multiply to A, it won't affect A, but it still give us back our what? A. So this is what checking for identity actually implies. So we're going to pick just a value, and then we'll see what the identity should be. Now looking at this now, what do you think is identity for addition? Now remember, for addition, now let's talk about the one of addition. You notice the identity for addition in anything, the only number that once you add to any other number, if you are adding to a number, it doesn't affect in addition, it's always what? 0. But if you check our natural number here, the sequence of natural number, we don't have 0. So it's actually saying that what? It does not hold, identity does not hold for what? Addition under what? These natural numbers. But if you go to let's say subtract the multiplication, I mean, and the multiplication, let's check. If you check for multiplication, what number can I multiply to enable one to give me the same number? Of course, I can say my identity element is 1, because here says if I multiply my identity element with any of the element, I should be able to get the same element, not the identity element. So if I pick 1 as identity element and I multiply it by 3, I will still get the same 3. So here 1 is my identity element. As you can see now, this one has started failing already. So you see there is a pitfall now in this side. So let's move further now to check for what? Inverse. Now let's check for inverse. And what does it mean? Inverse said, if I have an element G, element of a natural number, and if there exists G inverse, okay, remember we're dealing with what? If there exists what? G inverse. So if you notice here, there is no, like I said earlier, if you are dealing with numbers like, let's say 1, the inverse of 1 is what? Minus 1. If you have a 2, inverse of 2 is what? Minus 2. Are you getting it now? But if you notice here now, it's more like the G inverse, or let's say 1, and then 1 inverse does not exist. So since 1 inverse does not exist, even though I add it to anything, the inverse will not exist. What if I multiply it with anything to give me back my identity element? It will still not what? Exist. So it actually means that what? Inverse does not exist for both multiplication and what? Addition under what? These natural numbers. Because if I say, okay, under multiplication, because I need to multiply them so that they should give me back my natural number, my identity element, all right? That is actually the most important thing. So I should get back what? My identity element, which I got to be what? 1. That is with multiplication. Remember that this one doesn't even have identity element, so no need of bothering looking for inverse. But this one that has identity element 1, now for multiplication, let's consider it. So if we go to 1 times which number will still remain 1? Nothing. If I say 1 times 1, I have not made any move, so automatically this doesn't have what? Inverse. So from here, we can say that this, since it does not fit into this other group, so it can never form a complete group. Rather, it forms what we call what? A semi-group. So it is a semi-group, or we can call it what? Monoid. It is either called a semi-group or what? Monoid. So, but then it's not even a proper monoid. It's a monoid when it is with multiplication, because it satisfies three axioms. But when it is with just addition, addition just gave us this is simply we call it. So we call this with the other one we just actually call it was subgroup or semi-group. We can call it was semi-what group. So you notice that what they actually said, the statement said here, is actually correct. So we have shown that the set of natural numbers 1 to infinity does not form a group with addition or subtract or multiplication, but it forms what we call a semi-group with respect to what? The addition and as well as what? Subtraction. So this is Machine Learning website. Do feel free to subscribe to this channel. Thank you.